Good morning, good afternoon, good evening to everyone from wherever you may be joining today. I'd like to say firstly, thank you for signing up to this session, this webinar. We are going to be looking at next generation antenna multi-orbit, multi-network, defining new standards. We're very excited about this webinar, and even more so when I come to introduce the panel of experts that we have joining us today. Next generation antennas, multi-orbit, multi-networks are the forefront of shaping the future of satellite communications. However, there's been a lack of collaboration among operators, component manufacturers to establish a unified framework for FPA requirements and performance standards. A roundtable discussion organized by SIG and GSOA during Satellite 2024 sparked significant interest in flat panel antennas, and there is a clear agreement that we've been too slow to act. With new standards, new orbits, as well as significant FPA products now in play, we must act, and the timely approval of electronic steerable antennas, crucial for tracking satellites across orbits without causing interference, hinges on standardized FPA protocols. In this dynamic landscape, collaboration and standardized protocols play a pivotal role in realizing the full potential of multi-orbits and multi-network connectivity. We must ask ourselves, are FPAs truly delivering to promises made for so many years? And why can't we get a standardized set of requirements for testing? We are already too late, but we must stop talking and bring new standards to our industry so that it can flourish in this new world of multi-orbits and multi-networks. I now would like to introduce you to the great panel that we've assembled today for this session. They bring years and years of experience, and I will allow each of them to introduce themselves individually, and I will start with Colin.
Thank you, Mark. My name is Colin Robinson. I've got about 50 years of experience in the antenna business, both with aircraft, missile, satellite antennas, some microstrip arrays, and design of test facilities, including antenna pattern ranges and RCS test ranges. I've conducted close to 90 to 110 VSAT type approvals over the years. I served as the GVF MRA chair for 20 years and headed up the GVF MRA type approvals group. I'm also a NATI engineer, that's an EMC engineer. I hold a number of patents in the field and approved authorized test entity. I enjoy working in this background. It's a very important field for us, and I approach it with enthusiasm. Back to you, Mark.
Okay, thank you, Colin, and thank you for joining us today. Andreas.
Yeah, my name is Andreas Voigt. I'm working for Eutelsat, a senior engineer in the Service Operations Center, CSC, of Eutelsat, and taking care about all of the consultancy and also incident problem change management tasks that require senior attention. I have experience for quite some time, for sure not as long as Colin. I'm a little bit younger, but not so much. So my first antenna I built up in 1987, so that's also something. And a professional in satellite communication since 26 years now, so since 1997. Therefore, I'm given quite some experience in the environment. As you know, Eutelsat, we are a true LEO and GEO operator in the world, and therefore the question of flat panel antenna is something that is very important for us in the business development, and for sure also in incident avoidance for the work in the control center, that everything seems to be absolutely right. And that is something we need to combine together and do all the necessary stuff jointly with other satellite operators and with the industry to bring that particular part of hardware in the telecom pivot forward. Back to you, Mark.
Andreas, thank you. And again, it's a pleasure to have you on this panel today. Let's go across to Bill.
Thank you, Mark, and welcome everyone. I'm Bill Milroy. I'm the CTO here at ThinCom. We're a phased array manufacturer based here in the US in Hawthorne, California. We're perhaps best known for our KU and KA band thin air systems that operate on both GSO and NGSO. So they are multi-constellation, multi-orbit. And we're flying on some 1,500 commercial aircraft. Perhaps not as well known as we're on quite a few government aircraft as well. So we have a lot of experience in the industry. Our phased arrays support both FCC and ETSI licensed GSO and NGSO SATCOM systems for companies like Hughes, Inmarsat, Intelsat, Eutelsat, SES, and even here in the US, the Department of Defense. So today's discussion is certainly a front and center for any CTO at any company, particularly a phased array company. I'm looking forward to today's discussion, evolving, around our evolving and challenging efforts to standardize the way we characterize and approve our phased array systems. Back to you, Mark.
Bill, thank you again, and thank you for joining us today. Looking forward to your input to the discussion today. Over to Joachim.
Thanks, Mark. Hi, thanks, Mark, and thanks for having me today. My name is Joachim Espeland. I'm the CEO and co-founder at QuadSat. We develop and put to market test solutions for satellite antennas. We have done that since 2017 when we started a company around the same time as the SOMAP initiative was announced. We've in the last years experienced quite a rapid increase of demands in testing for flat panel antennas. So this is something that we're focusing a lot on now as a company. I have myself a background with over 10 years of working in the satellite industry, primarily in antenna testing. So I'm very much looking forward to this panel today and to move this further along.
Thank you, Joachim, and welcome. So as you can see, we have a great panel assembled for today's discussion. So let's get this going. FPAs, ESAs, they've been around for a long time, lots of promises, and some will say we're still waiting. They haven't delivered, but obviously there are a number of manufacturers now producing antennas that are installed on a worldwide basis. But I think a great place to start is why FPAs? And I'm going to lead this or hand this over to Colin to discuss why FPAs are critical to our industry today. Colin.
Thank you, Mark. Well, let's turn back the clock a little bit. The satellite industry largely focused the design of its products before about 2010, 2000 on parabolic antennas. And the ITU regulations, let me get some different glasses. Some ITU regulations are based around these. These are primarily for GSO orbits. In about the 2010, 2013 period, and there was increased interest in evaluating the emerging flat panel antennas to serve the LEO-MEO market. And at that time, it was difficult to justify spending the kind of money to develop a tracking system in the flat panel antenna. When you're looking at, for a traditional VSAT antenna, a manufacturing cost, non-tracking of about $20 to $40. But as the industry evolved, we've seen staggering growth in the industry. By about 2022, I checked through the US Accountability Office, there are about 6,500 satellites in various orbits in 2022. By the end of this decade, that number is predicted to be 65,000. And most of this growth is attributed to the LEO-MEO market. So that's going to be putting high demand on the technology and how we qualify these products. If you go to some of the ITU regulations, I'll pick a few, for example, the 580-6 acknowledges the fact in their note 2 that further study of microstrip antennas is required. If you look at ITU 1428-1, there's a comment there that questions the advisability of using specifications applied for paraboloid antennas to flat panel antennas. It's an open question that really hasn't been answered, in my view, by the industry. So what are the demands for the marketplace? Well, with the increased LEO-MEO populations, we're going to have faster tracking, and this kind of favors microstrip or ESA solution. The orbital height also influences the designs. If you take like an O3b satellite, it takes about 8 hours to cross the field of view, and so it's a fairly slow tracking arrangement. And for O3b, most of this has been accomplished through physical tracking with parabolic antennas. But definitely for the lower Earth orbits, 500 kilometer orbits, there we have fast tracking, and for reliability standpoints, we don't want a mechanical solution. The advantages of the ESAs are low profile, high reliability because you haven't got the potential for mechanical failures. You can create multiple beams, much lower latency, and these are all advantages. Some of the disadvantages, and they're not killers for the product, they're less efficient because you typically have a more lossy RF distribution network. Some of this can be mitigated by having individual elements addressable and the electronics built into the back of them. The challenges, however, for this system are as you sweep an antenna, an ESA antenna pattern off axis, off its normal mechanical pointing axis, the gain of the antenna decreases by about the cosine of the scan angle. And if you're scanning over very, very wide angles, you can lose about upwards of 15 dB in gain. So really, that's going to be a challenge for the industry. Fortunately, some of the higher volume operators are limiting their look angles to about plus or minus 20 degrees, and that's probably going to be acceptable. But I would question using a flat panel to scan from horizon to horizon. Along with the reduction in gain with the off-axis scanning, we also see an increase in the half-power beam widths. So it adds the potential for causing interference. So we've got to take special precautions to prevent that. Another problem with this is that as you scan off-axis, you get the development of what are known as coma side lobes, and these can be higher than the current ITU specs will allow. Again, potential for interference. So back to the ITU regs, the recognition that we have to, I think now, take a look at applying different standards for flat panels and ESAs that have been applied to the traditional paraboloid antenna market. One of the approaches that's being considered here is the testing. Because the antenna pattern changes with each scan angle, unlike a parabola, which keeps a stable antenna pattern, to fully characterize these antennas, if you did it traditionally, would take thousands of antenna patterns. Again, you're concerned about the areas of interference increasing with high scan angles. One approach that's been considered, and kudos to ThinCom for supporting this activity, was to come up with a procedure whereby if we could get software to predict the performance of the antenna, and then use that to compare the performance of actual ESAs and look for areas where there are violations of the specs. Eutelsat has coined, I think, a very apt descriptor of this. They refer to it as the digital twin. And this, I think, is a very powerful technique, and it will cut down on the amount of testing, allowing you just to do characterization of the important areas, but provide the provision for investigating the performance in areas where you may be close to meeting a spec line. Another option that's being considered for test facilities, we've been looking at new test facilities, and UAVs present a unique opportunity that you can't achieve in the standard compact or far field range. And here we can perhaps emulate, and I'm sure there'll be more discussion on this, but emulate, say, a satellite in a geostationary orbit and a second LEO antenna, and evaluate the levels of interference that are encountered. This will allow you to determine what kind of restrictions and protections you have to put in place to protect interference from the LEO services to GEO services and to other LEO services. So it's a very powerful opportunity. I'm going to leave it there, but that's just a snapshot of where we are, and I'll turn it back to you, Mark.
Colin, thank you so much for that. That was really appreciated, and I think that set the landscape extremely well for the rest of the discussion here. So thank you for that. I'm going to post a question to you, Bill. You know, obviously there's been a lot of innovation for ESAs, FPAs. Those of us that were at the satellite show, there's a lot of technology that was on display in various states of readiness. Are we now at a point where we have reliable products at the right price that can deliver the promises that have been made for so many years?
Wow, well, that's a pretty complicated question. We at ThinCom would concur that reliability is a really key metric, you know, whether that's on an airplane or on a ship or on the ground. We believe we've been pretty successful. We think setting the standard there, you know, with around 50,000 hour mean time before failure. We have about 45 million operational hours with our system. So it's something we've really worked on hard, and I think have been successful. And price, that's a given, is of course key. You know, depending on a consumer product, that might be a different price than on an enterprise product. That might be different than a price on a high survivability government platform. But across the spectrum, prices is really important. So and I'm sure, I know that all of our competitors are always sharpening the pencil, if you will, in terms of getting that price down. But in terms of cost, you know, I just want to remind everyone, or just kind of observe, that that's really a multifaceted part. So there is of course the purchase price of the system itself, whether that's at the store or by contract. But there's the total cost of ownership. So that includes a lot more things in the total cost of ownership, some of which is very relevant to what we're going to be talking about, or what we are talking about today. So that includes things like installation cost, maintenance cost. In the case of FPAs on a plane, the drag and the fuel burn, the carbon footprint are of course all very important. But last, but I would say definitely not least, is the bandwidth efficiency. So by bandwidth efficiency, I mean squeezing more megabit per second, if you will, from the least amount of megahertz, because that's a recurring cost in terms of the leasing of the satellite. And some people sell their services by the megahertz, some sell by the megabit per second, but particularly the people who are leasing their capacity by the megahertz, they care about getting the most data from that expensive, or coming down in price, but from those megahertz. So as we, you know, the other parts that go into that would be, from an antenna standpoint, get a little bit more techie here for a moment. would be the G on T. That's the receive sensitivity of the antenna, and that's each system's a little bit different. Obviously, you want to get the most sensitivity with the smallest possible antenna. So this goes to the overall efficiency on the receive side. But really specifically relevant to our discussion here would be on the transmit side. So on the transmit side, the uplink side, you want to be able to transmit at the highest possible data rate, of course, and you want to be able to go at the highest power level in order to achieve that. But in doing so, the regulatory requirements, rightly so, limit you in terms of what you put on other people's satellites. So, you know, that's fine. You can work that out with your particular constellation provider, but it's a given that you need to not splay your, radiation onto other systems. And if you do, then what you'll have to do is you have to reduce your EIRP or increase your spread, and there goes your efficiency on the return link. So there's definitely a cost associated with these regulatory requirements. So we don't want to just throw the most extensive regulatory requirements. There is an unintended consequence from that, and that all goes back to price. So also I want to point out one point, building a little bit on what Colin said with respect to types of FPAs. There are LEO-only FPAs. So some of the advantages of a LEO-only system are, because LEOs are at very much lower altitudes, lower slant ranges, you can get away with a lower G on T, a lower EIRP in order to communicate to those satellites. However, we're finding that many users want to be multi-orbit, meaning they want to work with GEOs as well. So the challenge there from an FPA standpoint, or from a system engineering standpoint, is these GEO satellites, of course, are further away and require, for adequate or similar performance to a LEO, they need much higher G on T and much higher EIRP. So there we go back to the whole cost standpoint. So as an FPA supplier, our challenge is to provide the most reliable, lowest total cost of ownership system that also has the ability to meet the regulatory requirements incumbent on us in order to make sure we can do these really nice return data rates as well. So really, it's all about protecting the GSO satellites. There's been, for some time now, we've been protecting GSO satellites from other GSO terminals. But now there's new regulations, or some of them are not even new. Some of them are old, but they've been kind of dusted off now that NGSOs have finally gotten here. And those are NGSO operators making sure that they don't impinge on the GSO operators who are operating the same frequency band. It's NGSO operators making sure they don't impinge on other NGSO operators. And there's even, particularly in the case of aircraft and maritime, requirements to make sure that satellite operators who are using certain frequency bands, particularly the millimeter wave bands, are not impinging on terrestrial users who are using these for 5G services. So it's gotten very, very complicated. We're all using the same or similar frequencies. And so that segues us back to this whole point of our discussion, that we need some standardization in how we characterize the antennas and how we regulate the antennas as well. Back to you, Mark.
Well, Bill, I really appreciate that answer to the loaded question I gave to you. So let's take a look at it from a satellite operator's perspective. Andreas, you know as well as I do, there's a multitude of ESA technology, flat panel antennas. We've seen them. What do you think is the biggest challenge to the wide scale adoption of these products?
Well, the wide scale adoption, Mark, to be very honest, has already taken place, because we can see thousands of these antennas already in service for both for airlines, for whatever kind of thing that has maybe not a white color or a gray color, but maybe something khaki. So they are already in a multitude inside the service. Nevertheless, we have to say one particular thing. For the low Earth orbit environment, we are still in the build-up of the systems. And we would like to have, when it is built up completely, multiple links to multiple LEO satellites and maybe a GEO satellite at the same time for redundancy purposes, or maybe for TV watching or whatever kind of thing. So we're talking about multi-link structures. And here for sure, as a little addition to what Colin said earlier, we need to have flat panels, because Metal reflectors can't do that. Multi-links cannot be done by reflector antennas. We need to have flat panel ones. And that's why we need to make it right. And we need to make it still right while even having so many of those already in the environment. Why? Because the orbit build up and the new generations which are coming of the satellites are going to be even denser inside low Earth orbit. So we need to have a higher GeoBT requirement. We need to have a more bundled beamforming and so on. All of the things which Bill has 100% correctly pointed out some minutes ago. That is something to avoid interference and to have the best possible megabit per megahertz ratio, which we can offer to the customers. And that is a very important thing, because if you have already used the environment on the plane, where you share it with many of the people inside the environment of the plane, while having the beam also illuminating several of the airplanes, then for sure you can see that the individual return channel bandwidth is not really very big, but it is big enough to do surfing, to do streaming, to do all of the necessary stuff, even sending emails with attachments and whatever. It takes a little bit longer than when you do that from ground, but it works very well. And the price value is also not bad at all. For a businessman that would like to be connected on the flight between London and New York, he can work and do the things properly and have a good connection in the environment. Everything is possible today already. So now let's go forward. As a director for SIG, I'm speaking also with other operators, and we need to make it right, because we don't want to interfere with others. We need to have a look how we are going to protect neighboring satellite environment, and we need to test and approve these flat panel antennas with the more denser and denser low Earth orbit environment coming up. It is even more important. So therefore, we need to have a look very closely how to do that. So shall we go ahead and pick up the things what we have had with SOMAP earlier for the metal environment? I would say so. And additionally, the idea is to come up with a digital twin environment, as Colin said. What is that? That is a software that emulates the capability of the antenna, which can be presented to the satellite operator or the SOMAP environment for approval. For sure, the software needs to be approved as well and tested out, but it makes the whole thing easier to approve. Why? Because otherwise we need to do 300, 400,000 test points with the help of Joachim, for example, at QuadSat. Eutelsat has recently signed a cooperation agreement with QuadSat. Thank you very much, Joachim, for that. That brings us very much forward inside this antenna testing environment. And as a member of SIG, QuadSat is for sure introduced and implemented in this environment between the satellite operators and the hardware manufacturers and the testing software providers and so on. So that is really a great thing to go forward in applied software solutions and antenna ideas. So where do we need to go? We need to have this kind of protection. We need to go ahead and find out the potholes of the antenna design, because the antennas are moving, the satellites are moving. We need to have multiple link environments for multiple frequencies. Some people even say multiple bands, so that we have KU band and KA band on the same antenna. For sure, we cannot do miracles. We need to go one step after the other. And we cannot put everything together in one antenna, because otherwise the industry is not going to pay for that. As Bill has said very well, it is a price question also for the quality of service you would like to have. So I would like to remind, for example, how to get over with the scan angle problem. If you tell the antenna ephemeris data of the satellites they would like to have, and the antenna has also a GPS receiver in it, the antenna knows where it is. It has a time signal and can process the ephemeris data directly and have a look approximately where the satellite is. So therefore, the scan angle of the antenna is very, very much reduced, maybe to 5 or 10 degrees. And therefore, a horizon-to-horizon approach is not necessary anymore. And the antenna also knows where the next satellite is. The antenna also knows where the GEO satellite is. So therefore, it is pretty easy to go ahead and give the antenna a certain help to go ahead. It's the same with the LEO satellites. All of them have GPS receivers on board. They know where they are. Therefore, they can fly conjunctions which are possible inside 500 meters, 1 kilometer distance for geosynchronous satellite operators. That's way beyond any alarm environments. We need to face this new technology. This is coming from new space, and not everything what new space is giving to us shall ring alarm bells. No, we should go forward and foster that and bring that together to have a combined GEO and LEO solution for the good of our company and for the good of our customers. Back to you, Mark.
Andreas, thank you so much for that. As always, it's a pleasure listening to your passion as you describe these issues in our industry and ways forward. So, you know, from a satellite approval, let's take a look at the FCC. Obviously, over the last number of years, there's been a number of discussions around FCC regulatory requirements for ESAs. And Bill, I think you're probably best placed to give us your views on what's wrong with the FCC. What's the problem? Maybe a little bit loaded, but I think
I should be careful here because
place.
it's good to, I could get in a lot of trouble. So I'll take the high road though. So with only a few exceptions as of late, the FCC and also the ITU and the ETSI requirements were, in many cases, again, several decades ago, crafted specifically and almost solely for circular parabolic dishes. So by circular, I mean ones that have the beam width is pretty much the same in all the different cuts. The side lobe structures are approximately the same in all the different cuts. So in that case, even a single antenna pattern or maybe a pair of orthogonal antenna patterns was more than enough to characterize those parabolic dishes. The parabolic dish also, of course, if it's fixed on a GSO satellite, it's static, its patterns don't change. But if it is being used on a LEO, then its characteristics, its gain, side lobes, and so on and so forth are still independent of elevation angle. So the history there is that we're pretty much still have regulations that are based on circular parabolic dishes. And notwithstanding the nuances of non-circular shaped dishes or flat panel antennas, phased arrays are somewhat more complicated. They have the gain and pattern dependencies, the beam widths, the side lobe structures and such are a somewhat complicated function of the elevation, the azimuth, and the skew angles. And we've already spoken about a few ways we might characterize that, digital twin being probably one of our favorite ways of doing that. But based on these practical considerations, it's going to require some collaboration and some motivation to make this happen. So, for instance, I'll pick, if you will, on the U.S. Department of Defense, we, as many of our competitors, sit on a group that works with the WGS satellites, the regulatory group, the RSTRAT group, that has to come up with requirements required to work on the U.S. WGS constellation. And we meet as an industry every couple of years. The government meets more often, but the challenge there, we really don't see much change in the regulations. There's a lot of reluctance to change it. We understand what that would be. But you know, now I think, based on what some of my fellow panelists have mentioned, the NGSO satellites, they're here. You know, that even in some of the earlier licensing and approvals, there was always this anticipation that NGSO satellites would be there, and we need to do something in the antennas to anticipate the future possibility of NGSO satellites, which was not very rigorous. But now NGSO satellites are here, so we need to respect them and not interfere with NGSO satellites. And of course, the NGSO satellites, both on the satellite side and on the terminal side, have to be respectful and not interfere with GSO satellite operation. So that brings us to where we are. The NGSOs have pressed the flat panel systems in terms of performance, in terms of being now multi-beam and multi-constellation and regulatory. And then I'm just about wrapping up here, Andreas. And then I'll leave it over to you. So there's much to consider here. It is complicated, and we'll, how can we get this done? But we definitely, the time is here. The pressure is on us all in the industry to make this happen, and to make sure that we maintain interoperability, interference-free interoperability, both now and in the future. And I'll leave it back off to either you, Mark, or Andreas.
Andreas, I think you had a question there.
No, I just had a little remark, which I would like to share with all of you. As you know, the non-GSO operators have the license agreement signed that they do not interfere with geosynchronous satellites in downlink or uplink and so on. And here it is important to see that they have that implemented in their software environment. And since the start of Starlink and OneWeb and so on, neither SES nor Intelsat nor Eutelsat, and we share our results in SIG, have ever seen an interference coming from a LEO satellite into a geosynchronous link. I think that is, with the number of Starlink, OneWeb satellites around, that is already something like a marvel. And it shows that these kind of restrictions in the software environment are well established. We are not afraid about that. GSO and non-GSO, even while using the same frequencies in transmission and in uplink, in downlink, sorry, this is pretty much solved. The other thing that we have to prevent LEO to LEO interferences, which are even shorter and for sure more difficult to in the environment as well, due to the location-based geometrical environment of conjunction. That is something which we need to look at more carefully and implement that as well, prior to going to big escalations and ask for the questions of regulatory and licensing environments. So that is something which maybe even the antenna industry for FPAs is not going to attack. So I don't want to go further on that, because let's stay in the FPAs. Back to you, Mark.
Thank you, Andreas, and thank you, Bill. So we've heard from the operators what they would like to do to prevent, interference and maintain a business operational model. We've heard that the FCC is a little bit behind the times and still aligned probably to parabolic antennas and approvals. So from a testing perspective, we're going to go over to Joachim and get his view on what does he think about standardization, what should we do, and how should we do it? Joachim.
Yeah, thanks, Mark. Yeah, standardization is really important, because if not, it becomes really difficult to develop new systems and push innovation forward. And if we fail to innovate as an industry and have delayed innovations without a common framework, it gets harder to push these boundaries and leaves us as an industry entirely behind. And that makes us miss out on big opportunities or new markets that where a satellite solution might be good, but if you can't have the right equipment or new innovations, then you might have a challenge. It also increases the barrier to entry for newcomers to our market. if you're starting up or have an idea for a new technology, it becomes very difficult when you don't know how to fit it on to a market, and ultimately might lead to compatibility issues in the industry. So I think it's incredibly important, as we've talked about on the call here today, to sit together and use the resources that we have. We have the skills in the panel here and in the industry. There's a lot of interest to get FPAs standardized and so that we can run these tests. So it's a lot about collaboration on bringing it forward, and I certainly believe that is the right way for our industry to come to consensus. So yeah, so that's how I see it, and I believe that we in QuadSat, we have a lot of value to bring there with the new technology that we're bringing out with a very flexible test setup that can measure and test a lot of these challenges that there is on a flat panel antenna, and that can also create an environment where data can be shared or information can be shared and discussed and find the right conclusions going forward.
Okay, Joachim, thank you for that. Quite clearly, we have problems, whether it's from an operator perspective, whether it's from a regulatory perspective, manufacturer perspective, to get standardization. So, Colin, do you see a way forward in getting all of the parties together to be able to get to a minimum set of standard requirements to help industry get these antennas approved and into the marketplace early, driving innovation in the near future?
I certainly, as you pointed out earlier, we're probably a little late from the starting gate addressing this problem, and but I do have hope for this. I think, as Eutelsat has noted, there's the good news is there haven't been many cases of interference so far. So I think we've got some time to address this issue. I would like to sort of bring your attention to the SOMAP group. This group is a group of 5 satellite operators: Intelsat, Eutelsat, SES, formerly Inmarsat and AsiaSat. This group, all competitors, have worked very well together in coming up with a minimum set of performance requirements. Why do they do this? Well, part of the reason is there are different specifications, and formerly the GVF-MRA process, which was a recognized type approval process, defined what the test requirements were, but the operators all complied with 580-3, but also had, which was a requirement, but also had the additional specifications imposed on the top of those. So operator to operator, there was some differences in what they required for a full type approval. Once that type approval was granted, a cost-saving innovation was that other satellite operators could accept the type approvals undertaken on behalf of one operator for their operations and deploy products without further testing. If, for instance, a particular requirement, say a Eutelsat requirement for high cross-pole performance hadn't been tested for another application, then obviously that wouldn't satisfy a Eutelsat requirement, and additional testing would be required. So I think the starting point of this is the satellite operators are key in coming together and setting up boundaries on what they see as the accepted interference levels that they can live with. I don't know how difficult that's going to be, but I think there's some of the conditions that have been in place with the existing ITU regs can give us some guidance there. Then I think we definitely need input from the manufacturing segment. We do not want to create specifications that drive up the costs of getting these products to market. There are other competitors in this market, and we want to make sure that the satellite solutions are the leaders in the solutions that customers have. So it's going to be key to get the input from manufacturers so that we don't over-specify. If we can plan to extend the mission of the SOMAP group, maybe create under another working group to come up with regulations that are acceptable to the satellite operators, frame some recommendations, and then present those to the ITU as recommendations from across the industry to address the challenges that have been presented by ESAs. I mentioned some of the advantages earlier of the ESA antenna solutions. There are some one or two things that we have to consider, and I think Bill pointed out this. Because of the narrow band of some of these solutions, we do need a separate transmit and receive antenna to service the up and down links, as far as I understand it. With a reflector antenna, that is can be accomplished in one structure. The feed system is designed to cover both the uplink and downlink frequencies. So we may have to recognize those kind of restrictions as we develop these specifications. And I think that's really covered it. I don't want to take up too much time on this. We're moving on. Thank you, Mark.
That's great, Colin. Well, let's just take a side step here. There's a number of questions that have come in. So I'm going to open the floor here to the panelists and take a couple of these questions. The first question is, when we talk about multi-link, multi-orbit, and multi-band FPA, do we mean to use one link at a time and be able to switch to another one, but not use multi-link at the same time?
I'll take a shot at that. So I think yes and yes. So it's dependent. Most of the systems today, it's true again that most of the systems today are single beam, so they can move the beam from one location to another. Some do it faster than others, but a single beam that can work. After all, on GSO satellites, the ping time, that is the time between when you send a packet out and by the time you get a response, is in the order of 600 to 900 milliseconds. So there's a drive to try to reduce that. Some applications would benefit from that. So hence it's useful to use LEO satellites. And as already been touched upon, LEO satellites or NGSO satellites, more generally LEO, MEO, even HEO, they require, because they move, you can't stay on the same satellite for a long time. So you need to be able to move from one satellite to the other. But because of some of the specifics of the advantages of NGSOs and disadvantages relative to GSOs, GSOs are generally recognized for broadcast or for wide concentrated areas, the preferred way to go. LEOs are generally recognized for lower latency applications in general, the preferred way to go. So really you don't, if you want a solution that can do both, this then drives us to multi-beam, multi-simultaneous beam operation. And certainly we're seeing additional interest there. But to harken back to the earlier question, it is all about cost. So unfortunately, none of these features or capabilities are free. So the challenge for FPA suppliers, ThinCom and our competitors, is to provide the best value. So to provide a multi-beam solution that maybe costs a little bit more than our single beam solution, but to be able to provide that kind of flexibility that users want to see. Because you have to remember too, when people buy their terminals in general, particularly for aircraft, they don't want to have to change one every year. They don't want to have to change to the next newest frequency band or type of satellite or even modem. They want something that they can use and feel good about, for 5-10 year time frame. So in doing so, definitely multi-beam, multi-simultaneous beam, something that everyone needs to address.
Okay, thank you for that, Bill. And I hope we were able to answer the question that was asked. Andres, did you have something?
One particular thing I would like to tell here, which gives us a little bit of an interesting inside view. Because we have been working with SINCOM for sure, because of our customers in the environment of aeronautical environment inside Eutelsat for many years already. And we have bought a SINCOM terminal to try out several years ago. I think it's something like 7, 8, or 10 years ago, one of the first environments. And for sure, when we switched it on and tested it out, it had a certain performance. And then we found out that we have quite a large number of adjacent satellite interference issue. And with the help of SINCOM and the new software, with the same antenna, the same hardware, we were able to bring down that interference by a number of dBs, more than 10, while even safeguarding transmission power from the environment, increasing G/T and the EIRP towards the targeted satellite just by software. And that is something which I would like to bring out here. We have the infrastructure in the environment already installed in the airplanes. And Bill, you're 100% right. The airplane industry, they would like to install the antenna and have that functional for the lifetime of the satellite in the best case. Airplane, I'm sorry. And an airplane has a lifetime of approximately 25, 30 years. That's for sure quite a long time. Yeah. And but if we are able to give software updates to these kind of antennas, for sure in the capability which they are able to do. So if it is a KU band environment, it is good for low Earth orbit satellites, and it is good for GEO satellites that operate in the same environment. So therefore, there is not really a hardware side to work with that, because it's proven that it works with GEO. And if it is working with GEO, it is working with LEO as well, because the EIRP and the G/T environments are less. So then we go further, and if we can do then the necessary software environment and give that hardware piece live 2.0 or 3.0 or 4.0, because software can go ahead and we can improve the system, then for sure that is an enormous and important amount of environment to make our ideas of multi-orbit, multi-link, whatever kind of thing for these flat panel antennas possible. And once again, flat panel is the only one who is able to do it. No metal antenna, no reflector antenna can ever do that. Back to you, Mark.
Thank you for that insight, Andres. Really appreciated. So quite clearly, we have a number of challenges across our industry. The big question at the end of the day is really who takes ownership of herding everybody together here? Who should lead it? You know, we've been talking about the same things for a number of years. We've not made a great deal of progress in some of these areas. Some companies have gone individual. Some companies have grouped and done a few things that have benefited the industry. Certainly, like some of the panelists' companies on our webinar today. But Colin, who do you think can bring this to fruition in a timely manner? Because to be quite frank, we can't be here next year discussing the same thing. There needs to be clear, decisive action, and it needs to be now, and it needs to be started now. So from your perspective, what would you like to see, and how do you think it should be led?
Okay, those are good questions, difficult answers. I think we need to build a consensus group that we've pointed this earlier, in which the satellite operators, using their experience, can provide us with the kinds of environments and concerns that they have, and what kind of specifications are needed to maintain the quality of service. So that's this input from the satellite sector. from the manufacturing sector, we need to identify people that will support this activity and then come together with a set of recommendations. How do we make that happen? Obviously, we have to try and create a group of qualified volunteers or people that can assign time to addressing these important problems. And I'm sure GSOA and SIG will develop some ideas for this that we'll put before this group, and certainly push participants in this call to join this effort, make a good contribution. I'd like to see us get to the point where we as an industry are very happy, very pleased, confident with the restrictions that we impose on ESAs, not to drive up the price, to provide quality of service. Once you have the whole industry behind that, then that will be the time to make the push to the ITU to say, to formalize it, to say this is what the industry requires. It's been vetted by the experts in the industry, and take it from there, make it a firm requirement. The first steps are going to be the hardest, to create the study groups to do this, but those are my thoughts. Mark?
Thank you, Colin. So it sounds like you're going to be busy over the next year.
Well, it's like volunteering. Everyone takes 2 steps back, and there's only one person out in front. So if I can, I will, but we'll see how it goes.
Okay, well, thank you for that. So, Joachim, where do you want to be in a year's time?
Yeah, I think it's important that we have a clear line from the development to uplink, basically, that the steps can be laid before being a manufacturer or being a user that is out buying, and you want to get on a certain network, that you have a clear line ahead of you on how to get onto that network, either that being a geo network or it being a hybrid or how it would be. So that's where I would like to see us be. And I think that, when we look back in the past, there have been introduction of communications on the move, for example. Was a major leap forward in the satellite industry, and allowed for a lot of new markets, and things needed to change, and the industry had to come together to set those requirements and build those specifications. And I think in the same way as Colin is saying, it comes together by, it's driven by the need. And what we will see now is, last year was a very bad year for investments, especially in new technologies. And that drives investors to push products into market. So whoever's sitting out there with investors behind them needs to have those products into the market. And I think that's a lot of the push that we're experiencing at QuadSat, is now that company wants to get on the network, they want to get their products out there, and we need to be able to help facilitate that, to ensure that they also gain the revenue that they need to innovate further and produce more and better products, and that are more capable.
Okay. Well, thanks for that insight, Joachim. I'm going to try and squeeze in one more question from the participants. It's probably a question that needs a lot more time than we have, but I'm going to give the panelists the opportunity to answer, and it's probably going to be a quick shot 30-second answer, but let's give it a try. So the question is, will there be a dual beam requirement for make before break when switching satellites in future LEO systems? Is this a must? We are designing beamforming RFICs and integrated antenna modules, and this has a big impact on the chip architecture. Your comments are valuable.
Well, I would say in terms of, there's a lot of exciting stuff going on in terms of chips, and not to leave anyone out with respect to companies like Anokiwave, Renesas, Analog Devices, that from an antenna standpoint, to have dual simultaneous beams does require on the receive to do that for the full aperture does require dual manifold systems, so a few more layers in the printed circuit board and such. So again, it's not free. From what we hear from from the users and also what we hear from the constellation providers is that this is a nice to have, but not necessarily a have to have. That is in terms of the true make before break, or, and then the next step up after make before break, which would imply a very fast switching system, is actually having simultaneous sustained capability on the satellites. So I would say it's a nice feature. It's a great feature to bring forward. I would not necessarily say, though, that it's a have to have. I would use Starlink as an example. Starlink, ESA, they've done a great job in terms of on the consumer side, getting that commoditized ESA in place, but that is a single beam ESA that, low G on T, low EIRP ESA. And so using Starlink, I wouldn't necessarily use them as the example of what we all need to be. But in that particular case, Starlink's made the choice that a single fast switching beam is the way to go.
Oh, thank you for that. There are a few other questions. I appreciate the participants sending some questions in. Those that we have not answered, we will get back to you directly. But we have reached the top of the hour. I would like to say a big thank you to all of the participants that have joined us today. I'd like to say thank you to GSOA and SIG for following through from our session at the Satellite 2024 show. I do hope that we're not asking the same questions of ourselves next year, and that we've made significant progress in our industry with this standardization. And most of all, I'd like to thank the panelists, Colin, Joachim, Andreas, and Bill. I really appreciate your insights and the information that you've shared today. So a really big thank you to you all. And I wish everybody a good rest of the day.